All right, this is the second day of Unit 7 notes. Today we're going to be solving polynomials that cannot factor. So last class we found the x-intercepts, also known as the zeros, roots, or solutions of polynomials using factoring. So that was a star method, factor by grouping, or difference of two squares. Unfortunately, like we've seen in the past, not every polynomial can be factored. So for polynomials that cannot be factored, we are going to use synthetic division to find all of our x-intercepts, also known as zeros, roots, or solutions. Remember, the way we figure out if a number is a x-intercept or a factor using synthetic division is when we have a remainder of 0. So our goal today is we're going to use synthetic division to divide the polynomial down to a quadratic. So remember, that means an exponent of 2. Remember, like I said last slide, a remainder of 0 means that the divisor is a factor. So once we have a quadratic, we will find the remaining solutions using either factoring or the quadratic formula. Now, the one thing we don't know is when we use synthetic division, we haven't talked about what we're going to divide by. We're going to come up with what to divide by using our P over Q list. So P is your constant term or the last term, and Q is your leading coefficient. It's kind of hard to explain, so I'm just going to show you in our first example. Alright, so like I said, we're going to use synthetic division to find our first factor and bring this down to a quadratic. But to come up with what we're going to divide by, I need to come up with my P over Q list. So Q is always your first number, and P is always your constant, the last number. I know that this is a negative 15, but for this sake, the signs don't matter. So what you need is you need to come up with your list of factors for Q and for P. So I know 1 and 3 are the only numbers that multiply to 3. For 15, I have 1, 3, 5, and 15. So I'm going to come up with my P over Q list, which means I'm going to take every factor of P and put it on top of every factor of Q. So I'm going to start by putting 1 over 1, which is just 1. I want to put 3 over 1, which is just 3. 5 divided by 1 is just 5. And 15 over 1 is just 15. The reason that your signs don't matter is your list is going to consist of the positive and negative of every single number. So I'm going to do the same thing. I'm going to take 1 and put it on top of 3, which is 1/3. 3 on top of 3 is 1, which is already in my list, so I don't need to write it again. I have 5 over 3, which is 5/3. And then I have 15 over 3, which is 5, which again is already in my list. So this list is all of my possible factors. So this is what I'm going to start dividing using synthetic division for. There's no science or rhyme or reason to this. I'm just going to start with the first number on the list and use synthetic division. So I'm going to drop down the 3. 1 times 3 is 3, so that's negative 2. 1 times negative 2 is negative 2, which is negative 49. 1 times negative 49 is negative 49, and I know right away that that will not give me a remainder of 0. So 1 is not a factor. So I'm just going to go to the next number on the list and try negative 1. So I have 3, negative 5, negative 47, and negative 15. So I'm going to drop down the 3. Negative 1 times 3 is negative 3, which gives me negative 8. This is positive 8, which gives me negative 39. And this gives me positive 39, which again, I know that won't give me a remainder of 0. So I'm going to keep doing this process until I find a remainder of 0. So the next number in my P over Q list is 3. So that gives me 3. 3 times 3 is 9, which is 4. 3 times 4 is 12, which is negative 35. And that's going to be negative 115. And I know that that will not give me 0. So I'm going to try negative 3. So I have 3, negative 5, negative 47, negative 15. So drop down to 3, that gives me negative 9, so this is negative 14. Negative 3 times negative 14 is 42, so that gives me negative 5, and negative 3 times negative 5 is 15, and I let negative 15 and positive 15 is 0. So that's my remainder. So that tells me that this negative 3, x equals negative 3, is one of my solutions. Now this is my constant, my x to the first power, and the x squared. So my quadratic that we wanted to drop down to is 3x squared minus 14x minus 5. So from here, I'm going to try factoring. If that doesn't work, then I use the quadratic formula. 3, 14, and 5 don't have anything in common, so I can start with the star. So if a times c goes on top, that's negative 15. Negative 14 goes on bottom, and 3 on the sides. So my two numbers that multiply to negative 15 but add to negative 14 is negative 15 and 1. That doesn't simplify, but this will drop down to 1 and negative 5. So my factors are going to be x minus 5 and 3x plus 1. So then from here, it's just like what we did last class of factor and solve. So I have x equals 5. So I do x equals negative 1/3. And then I have to remember our very first factor we found at the top using synthetic division is that x is also negative 3. So my three answers is negative 1/3, negative 3, and 5. Example 2, it's very similar. It's the same process. Keep using synthetic division until you find your perfect factor. Here, q is 1, and p is negative 6. My only factor of 1 is 1. 6, I have 1, 2, 3, and 6. So my p over q list is going to be 1 over 1, which is just 1, 2 over 1, which is just 2, 3 over 1, which is 3, and 6 over 1, which is 6. Because q is 1, that's just going to be my list. So just like last time, I'm going to start with my first number in the list and use synthetic division. So that's 1, so it's negative 6. That is 8, and 8, negative 6 will not get me 0. So I'm going to try it with negative 1. So these problems are just tedious because it's a lot of the same process over and over until you find the right answer. And that's positive 8, so that's 22, negative 22, which will not give me 0. So we're going to start with 2. And then try negative 2. So that doesn't work either. So we're going to try 3. So that's 1, negative 7, 14, and negative 6. So that's 1, that's 3, which will give me negative 4. This is negative 12. So that's 2, and that gives me positive 6. So here's 0. So again, X equals 3 is my first solution. I have my remainder of 0. So this is my constant, my exponent of 1, and my exponent of 2. So I have x squared minus 4x plus 2. I know that there's no two numbers that will multiply to 2 but add to negative 4. So I'm going to jump in and use the quadratic formula. So I have x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that gives me x equals 4 plus or minus the square root of 8 all divided by 2. And then remember, your next step is to break down the root. I have a pair of 2's, so that's going to give me 4 plus or minus 2. The pairs go on the outside, the loner stays on the inside, all over 2. And your last step is dividing out the triangle. 4, 2, and 2 all have 2 in common, so that leaves me with 2 plus or minus the square root of 2. So remember, we started with a degree 3 polynomial, so that means that my 3 answers are x equals 2 plus the square root of 2, x equals 2 minus the square root of 2, and then x equals 3, what we found in the synthetic division. So sorry I was running out of room there. So again, the hardest part or the newest part for you guys is coming up with that P over Q list. After that, you just keep doing synthetic division until you find a remainder of 0. Then either use a quadratic formula or factoring to find your last 2 answers. So here, once I started the notes, I decided to rearrange a little bit. This is going to be the try on your own problem. Your problem is x cubed minus 4x squared minus 11x plus 30. So again, come up with your P over Q list. Use synthetic division until you have a remainder of 0. And then you will either factor or use the quadratic formula. Good luck.